Hello, hello, and welcome to a little video about the introduction to systems. All right, so for these first few problems, all we're going to do is write our equations and not solve them, because I think it is important to be able to translate our English into math. Okay, number one, the Morton soccer team sold 500 tickets. Each adult ticket cost $12 and each student ticket cost $7. They made a total of $4,495. Let's write a system. Okay, so we have two things. One thing we have is the total amount of tickets, and we have how much money we made. So let's first start with the amount. We sold two types of tickets. We sold adult tickets, and that's a plus, student tickets, for a total of 500. So I would write total tickets here, just to remember what it was. Okay, we also have prices. $12 for an adult ticket and $7 for student ticket, for a total of $4,495. So that's total profit. Okay. Number two, I bought my first hour hot chocolate and donuts. Each donut was 75 cents and each hot chocolate was $1.40. My total before tax was $43.20. I bought 42 items. Let's write an equation. All right, so I'm going to start with the items. I bought donuts and hot chocolate, 42 of these items. I also spent money. I spent 75 cents on each donut and $1.40 on each hot chocolate. And I spent a total of $43.20. Wonderful. Number three, you decide to go on a romantic date to Taco Bell. You buy 3 tacos and 1 burrito. You spend $8.25. Your date buys 4 tacos, 3 burritos for 16 bucks. Let's write a system. Okay, so the two things in this problem are you and your date. So, you buy 3 tacos and a single burrito. I'm just writing B because you don't need to write a 1 in front of it. And I spent $8.25. My total. My date had 4 tacos and 3 burritos, spending $16. Number 4, you and your brother go to Foot Locker and buy some sneakers. You buy 3 pairs of shoes and 2 pairs of socks for $78. Let's pretend there's a giant sale going on to make this possible. Your brother looks up to you and buys 2 pairs of the same shoes and 4 of the same socks. He spends 60 bucks. Let's write a system. So the two equations we have here are the total for you and the total for your brother. Let's start with us. We bought 3 pairs of shoes, and I'm going to use K for socks, 2 pairs of socks for $78. Your brother bought 2 shoes, same ones, and 4 socks, same ones, for $60. Okay. Number 5. Marcus opens a new bank account. He deposits $25 that he won at a robotics competition. He also plans on depositing $10 a week that he earns from tutoring. Philip decides that he also wants to save money, because that's a great idea, Marcus. He already has $40 saved from mowing lawns over the summer, and he plans to save $10 a week for his allowance. Let's write a system. Okay, for Marcus. Marcus deposited $25. There's nothing you can do to change that. He also, plus, is going to deposit $10 a week to get his total. Philip, on the other hand, starts with $40 and also decides to put in 10 bucks a week to get his total. Okay, onwards we go. Number 6, Rachel needs to print some of her digital photos and is choosing between lightning fast photo and snappy shots. Lightning fast photo charges $5 no matter what, that's their base, plus an additional 20 cents per photo. Snappy shots, on the other hand, charges $7 for a base fee and then an additional 10 cents per photo. Let's write a system. Okay, so let's begin with lightning fast photo. Lightning fast starts with $5 no matter what, plus 20 cents per photo. And that's the total amount you're going to spend. Snappy shots. Well, snappy shots charges $7 to start and then 10 cents per photo. So depending on the amount of photos Rachel needs to print, she'll go either with lightning or snappy. Maybe they're going to cost the same. Maybe one will cost less. So this is where that would be important. Okay. The other thing I wanted to talk to you about are about numbers of solutions. Now, just like in the last unit where we just had regular equations, and when we solve them, we either get an answer, or we would get something false, which is no solution, or we'd get a true statement, which was infinite solutions. It's the same thing for systems of equations. Systems are just more than one equation. So we have the same concept, but I here have some graphing pictures for you as well. So the first case is one solution. And this happens when we have different slopes, and recall that in y equals mx plus b form, the slope is m. When you have different slopes, you will cross once, 100%. So one solution. No solution happens when we have parallel lines, and this is same slope, different y-intercept. Parallel lines never meet. They're very similar, but they never meet. It's a sad love story. The last option, just like in regular equations, is infinite solution. This is when we have two equations and they happen to have the same slope and same y-intercept. They might not look like it because they might be in different forms, but when you graph them or simplify them, they end up being the same line. So I know it's a little hard to see. I'm going to see if I can zoom in a little. Maybe you can see the blue and red line kind of one on top of the other. That means every part of the line overlaps. So, 3 types of solutions. One solution, crossed once. Parallel lines, no solutions. Same line, infinite solution. So let's take a look at these 3. Letter A, how many solutions does that have? Letter A has one solution. And it looks like it's at 3, 0. Letter B. Letter B also has one solution. And it looks like that's 2, 4. Letter C, parallel lines, no solution. We'll practice this some more in class. If you have any questions, please make sure to ask me or your teacher if they're using this video. If you are doing this with me, with Gumin, don't forget that these notes are available for you on Formative as well as on Teams. Have a wonderful rest of whatever day it is for you. Bye!